हेलो स्टूडेंट्स, वेलकम टू सूर्यवंशीज मैथ्स एकेडमी। आज हम ज्योमेट्री के हॉट प्रॉब्लम्स देखने वाले हैं। हॉट प्रॉब्लम्स के बच्चों कभी डरने की ज़रूरत नहीं है। अगर आपके कंसेप्ट्स क्लियर हैं, वो पर्टिकुलर टॉपिक्स के सारे कंसेप्ट्स आपको पता है, तो कोई भी सम आपको सॉल्व करने में प्रॉब्लम नहीं आना चाहिए। देखिए फर्स्ट सम, quadrilateral ABCD. In quadrilateral ABCD, segment BC is parallel to AD and AQ is 1/3 of AC. AQ is 1/3 of AC and we have to prove DQ is equal to half of BQ. Students, if you know the relation between AQ and QC, then definitely you can prove DQ is equal to half of BQ. But in this case, they have given the relation between AQ and AC. You know, if you prove these two triangles similar, you'll able to find the relation between AQ, QC and DQ and BQ. But before that, see, AQ is equal to 1/3 of AC. Let AQ is equal to X. Then AQ is equal to 1/3 AC given to us. AQ is what? X. X is equal to 1/3 of AC. So AC is equal to 3 into X, that is 3X. We got a relation between AQ and AC. AQ is X, AC is 3X. Will you be able to find QC? Yes. How? You know, AQ plus QC equal to AC. So what is AQ? X plus QC equal to 3X. So QC is equal to 3X minus X, that is 2X. AQ is X, QC is 2X. Then what is AQ upon QC? AQ upon QC is X upon 2X, X cut, that is 1/2. Suppose this is number 1. Now tell me, will you able to prove these two triangles similar? Yes. You know, these are the vertically opposite angles and these are alternate angles. So in triangle AQD and triangle CQB, why did I take this correspondence? Because you know A is equal to C, D is equal to B. So if I take AQD, I need to take triangle CQB. So in triangle AQD and CQB, you know, angle AQD is equal to angle CQB, or you can write congruent also. Why? Vertically opposite angles, and angle QAD equal to angle QCB, alternate angles. So triangle AQD is similar to triangle CQB. By which test? AA test of similarity. Since triangles are similar, their corresponding sides are in proportion. So AQ upon CQ is equal to DQ upon BQ is equal to AD upon BC. See students, AQ, CQ, QD, BQ, AD, CB, corresponding sides of similar triangles. But you know, AQ upon QC is 1/2. So can I take DQ upon BQ is also 1/2? So therefore, if I take this as a number 2, so DQ upon BQ is equal to 1/2. So therefore, DQ is equal to 1/2 BQ. You write from 1 and 2. So DQ is equal to half of BQ. यही हमें प्रूव करना था स्टूडेंट्स. So next sum is, see, in triangle ABC, angle ABC is 90 degree, D is perpendicular to AC and lengths of some segments are given. AE is 4 centimeter, AC is 13 centimeter and BC is 5 centimeter. Using this data, we need to prove triangle ADE is similar to triangle ABC. We have to find DE and AD, and after finding DE and AD, find area of triangle ADE upon area of quadrilateral. Now see, for proving triangle ADE and ACB, you know angle A is equal to angle A common angle and angle AED is congruent to angle ABC. Why? Each 90 degree. Therefore, these two triangles are similar by AA test. If these two triangles are similar, you know where to find DE and AD using these lengths. Before that, you know AC is 13 centimeter, BC is 5 centimeter. We can find AB using Pythagoras theorem. So AB square plus BC square is equal to AC square. So AB square plus 5 square is equal to 13 square. AB square is equal to 144. That is AB is equal to 12 centimeter. Once you get AB, you can take corresponding sides of similar triangles. You know, already we have proved triangle AD is similar to triangle ACB. Therefore, AD upon AC is equal to DE upon BC is equal to AE upon AB, corresponding sides of similar triangles. So AD upon 13 is equal to DE upon BC, because we know BC 5 and AE 4, AB 12. Take these two pairs and these two pairs. Using cross multiplication, you will get AD is equal to 4 into 13 upon 12, that is 13 upon 3, which is equal to 4.33. And D is equal to 5 into 4 upon 12, that is 5 upon 3 is equal to 1.66, but 66 is recurring, so you will take 1.67. After finding AD and DE, we have to find area of triangle ADE upon area of quadrilateral BCED. You know, before that, if you know these two triangles similar, while taking the ratios of areas of these two triangles, you will take a ratio of squares of corresponding sides, because this is the theorem. If triangle ADE is similar to triangle ACB, you will take AE square upon AB square, theorem on areas of two similar triangles, because we know AE and AB. AE is 4, AB is 12. 4 upon 12 the whole square, that is 1 upon 3 the whole square, which is equal to 1 upon 9. But where to find area of triangle ADE upon area of quadrilateral? See, if area of triangle ADE is 1y, then area of triangle ACB will be equal to 9y. So what about this quadrilateral? Of course, 9y minus y, you will get 8y. So area of triangle ADE upon area of quadrilateral BCED is equal to y upon 8y, yy get cancelled, which is equal to 1 upon 8. Now next sum is, segment PA is perpendicular to line L, QB is perpendicular to line L, RC is perpendicular to line L, ST is perpendicular to line L. AB is 6, BC is 9, CD is 12 and PS is 36. We have to find length of PQ, QR and RS. See, if PA is perpendicular to L, QB perpendicular to line L, RC perpendicular to L, SD perpendicular to L, can we say all lines are parallel to each other? Yes, because all are perpendicular to same line. Let PQ is X, QR is Y and RS is Z. Now students, you know, if all lines are parallel to each other, you will write AB upon BD is equal to PQ upon QS, property of parallel lines. So AB is 6, BD 9 plus 12, that is 21, is equal to X upon QS. See, if this is X, this would be 36 minus X. So you'll write 36 minus X. Do cross multiplication. 6 into 36 minus X equal to 21X. So 216 minus 6X is equal to 21X. 216 is equal to 27X. 216 upon 27 equal to X. You can divide by 3. 3 9s are, 3 7s are, 3 2s are, 9 8s are. So x is equal to 8. So you got PQ is equal to 8. If PQ is 8, what about QS? Therefore QS is equal to 36 minus 8, that is equal to 28. Now let QR is equal to Y. What about RS? See, let you wrote QR is equal to Y. So you got QS is equal to 28. Now take the ratio BC upon CD equal to QR upon RS. What is BC? You know, 9. What is CD? CD is 12. This is Y. And what is RS? This is 28 minus Y. Because you know, this is 28. This is Y. This would be 28 minus Y. So again do cross multiplication. 9, 28 minus Y equal to 12Y. 9 8s are 72, 7, 9 2s are 18, 18 plus 7 minus 9y equal to 12y. So 252 is equal to 21y. So 252 upon 21 y. So y is equal to 21 1s are 21, 21 2s are 42. So y is equal to 12. That is QR is equal to 12 units. How to find Z? You know already RS is equal, this distance is 28 or this length is 28. Out of this length is 12. So what about RS? Therefore RS or Z is equal to 28 minus 12, which is equal to 16 units. आइए start करते हैं new sum. In triangle ABC, D is the midpoint of BC, E is the midpoint of AD. Ray BE intersect AC at point P, and we have to prove AP is 1 upon 3 AC. For proving this, students, we should do one construction because we need to use basic proportionality theorem in this case. So I will draw DF parallel to BP. Consider the triangle ADF. In triangle ADF, you know, EP is parallel to segment DF. Therefore, AE upon AD is equal to AP upon PF. What is the reason? Basic proportionality theorem. But students, we know AE is equal to ED. AE is equal to ED. E is the midpoint of AD. Now this is given to us. So given. Therefore AE upon ED is equal to 1:1. Suppose this is number 1. This is number 2. So I will write AP upon PF is equal to 1:1. Therefore AP is equal to PF. So you will write the reason. AP upon PF is equal to 1 from 1 and 2. So AP is equal to PF. Now suppose this is number 3. Consider the next triangle, triangle BPC. In triangle BPC, we know DF is parallel to side BP. Use the basic proportionality theorem. BD upon DC equal to PF upon FC. Reason, basic proportionality theorem. Again we know, but BD is equal to DC given So BD upon DC equal to 1:1. Suppose this is number 4, this is number 5. So PF upon FC would be equal to 1:1 from 4 and 5. So PF is equal to FC. We know AP is equal to PF, PF is equal to FC. Suppose this is number 6. I will write AP is equal to PF is equal to FC is equal to X. Say AP is equal to PF is equal to FC is equal to X. We have to prove AP is equal to 1/3 AC. We know, students, AP plus PF plus FC is equal to AC. What is the reason? A dash P dash F dash C. So X plus X is equal to AC. 3X is equal to AC. So X is equal to 1/3 AC. But I want AP instead of X. AP is equal to X, no? So AP is equal to 1/3 AC. So यही हमें प्रूव करना था. AP is equal to 1/3 AC. Next sum. In triangle ABC, lengths of AB, AC and AD are given 5 cm, 4 cm and 3 cm respectively. One more thing is given. Angle ABD is equal to angle CAD. Using this, we have to find length of BC, DC and area of triangle ACD and area of triangle BCA का ratio. Now students, you know, if one pair of angle is given, we need to prove two triangles similar. Which are those triangles? ACD and BCA. ACD and BCA. We need to prove these two triangles similar first. Using these two triangles, we can find BC and DC and then ratio of their areas. Now see, in triangle ACD and triangle BCA, I will write angle C is the common angle. Therefore, angle C is equal to angle C. What is the reason? Common angle. Angle CAD is equal to angle ABD given. Therefore, triangle ACD is similar to triangle BCA. AA test. Therefore, AC upon BC is equal to CD upon CA is equal to AD upon BA. How to write corresponding sides? AC upon BC, CD upon CA, AD upon BA, corresponding sides of similar triangles. Put the values. Do we know AC? Yes, it's 3. BC, we don't know. CD, we don't know. CA, it's 3. AD, 4. And BA, 5. Now take 3 upon BC equal to 4 upon 5 and CD upon 3 is equal to 4 upon 5. This ratio and this ratio, this ratio and this ratio. So 4 into BC equal to 3 into 5. So BC is equal to 15 upon 4. 4 3s are 12. 4 7s are 28. 4 5s are 20. And CD, 5 into CD equal to 4 into 3. CD is equal to 4 into 3 upon 5. So CD is equal to 12 upon 5. So 5 2s are 10, 5 4s are 20. After getting these values, we have to find the ratio of ACD and BCA. You know, since these two triangles are similar, area of triangle ACD ACD upon area of triangle BCA is equal to AC square upon BC square, which is equal to CD square upon CA square is equal to AD square upon BA square. Reason, theorem on areas of two similar triangles. Try to put the values, AC, do we know AC? Yes, we know AC. Do we know BC? Yes, we know BC, but it is in decimal. So instead of taking this, try to take CD and CA. CD, do we know CD? Again, CD is in decimal. Don't take this. Try to take AD and BA. AD is 5 and BA is, AD is 4 centimeter and BA is 5 centimeter. So you will take 4 square upon 5 square, that is 16 upon 25. So area of triangle ACD is to area of triangle BCA is equal to 16:25. Next sum, we have to prove 3 times the square of any side of an equilateral triangle is equal to 4 times the square of an altitude. Students, consider the triangle ABC, which is an equilateral triangle. In this equilateral triangle, AD is perpendicular to BC. This is the given part, and we have to prove 3AB square is equal to 4AD square. 3AB square is equal to 4AD square. Triangle ABC is an equilateral triangle. Therefore, AB is equal to BC is equal to AC. And suppose this is number 1, and BD is equal to half of BC, because in case of isosceles triangle or equilateral triangle, altitude bisect base. Altitude bisects base. So in triangle ADB, use Pythagoras theorem. ADB is equal to 90 degrees. So use Pythagoras theorem. AB square is equal to AD square plus BD square. Reason by Pythagoras theorem. So AB square is equal to AD square, but BD is half of BC, so half of BC the whole square. Suppose this is 2, from 2 AB square is AB square is equal to AD square plus 1 upon 4 BC square, multiplying throughout by 4. 4AB square is equal to 4AD square plus BC square. But we have to remove this BC, and BC is equal to AB. So I will write 4AB square is equal to 4AD square plus AB square from, suppose this is 3, this is 1, from 1 and 3. So 4AB square minus AB square is equal to 4AD square. 3AB square is equal to 4AD square. 3AB square is equal to 4AD square, और यही हमें प्रूव करना था स्टूडेंट्स. So next sum. In triangle ABC, angle A is 90 degree. AC is perpendicular to BD. And we have to prove AB square is equal to BC into BD. AD square is equal to BD into CD. And AC square is equal to BC into CD. बच्चों, जब भी सेगमेंट का रेशियो और सेगमेंट का मल्टीप्लिकेशन हमें इक्वल प्रूव करना है, at that time we need to prove two triangles similar. See, consider AB square, BC and BD. AB BC and BD. So we'll consider this smaller triangle and bigger triangle. After that, AD square is equal to BD into CD. AD square is equal to BD into CD. means ये छोटा triangle और एक बड़ा triangle. After that, AC square is equal to BC into CD. AC, BC and CD. Last में हमें ये दो छोटे triangles लेने हैं. Now, you know, in triangle ABC, angle A is 90 degree and AC is perpendicular to segment BD. So you will write this triangle is similar to this triangle. This triangle is similar to BAD and these two triangles are similar to each other. In short, I will write triangle. See how to decide correspondence of triangles. You know, this angle is always equal to this angle and this angle is equal to this angle. So if I take BAD, larger triangle BAD, that is circle 90 and take, that is BAD, and how to consider chota triangle? Circle 90 and tick means similar to triangle BCA. Circle 90 tick angle triangle ACD. What is the reason? Similarity of right angle triangle. Similarity of right angle triangles. Now consider first pair. So triangle BAD is similar to triangle BCA from 1. Write their corresponding sides. BA upon BC equal to AD upon AC equal to BD upon BA, corresponding sides of similar triangles. See students, BA, BC, AD, CA, BD and BA. Now we need AB square is equal to BC into BD. AB square is equal to BC into BD. So take these two ratios and do cross multiplication. You will get AB square is equal to BC into BD. AB square is equal to BC into BD. AB square is equal to BC into BD. Now for proving AD square is equal to BD into CD, you will consider triangle BAD and triangle ACD. You know, triangle BAD is similar to triangle ACD from 1. Take corresponding sides. BA upon AC is equal to AD upon CD is equal to BD upon AD. Corresponding sides of similar triangles. We have to prove AD square. Where is AD? AD. So you will take these two ratios. AD square is equal to BD into CD. You will get required answer. This is second. And for proving AC square is equal to BC into CD, you will take these two triangles. You know, BAD, BCA, ACD. So I will take, so this is first part, this is second part and third part. You will write triangle BCA is similar to triangle ACD from 1. BC upon AC is equal to CA upon CD, which is equal to BA upon AD. Same reason, corresponding sides of similar triangles. We need AC square. See AC, take these two ratios. AC square is equal to BC into CD. AC square is equal to BC into CD. Next sum. In triangle ABC, AB is equal to AC. This is an isosceles triangle and D is any point on BC. We have to prove AB square minus AD square is equal to BD into CD. Students, we need to use Pythagoras theorem in this particular sum. So I have constructed AE perpendicular to BC. You know, triangle ABC is an isosceles triangle. Given because AB is equal to AC. And AE is perpendicular. I will write construction over here. Segment AE, draw segment AE perpendicular to segment BC. So triangle ABC is an isosceles triangle given to us, and AE is perpendicular to BC. Construction. So I will write B is equal to AC because altitude in isosceles triangle altitude bisects base. Altitude drawn on base bisects base. So B is equal to EC. Now we can use Pythagoras theorem in triangle AEB and AED because AB square and AD square, AB square and AD square, AB and AD are the hypotenuse of triangle AEB and triangle AED respectively. So use Pythagoras theorem in triangle AEB. You know, angle AEB is equal to 90 degree. So AB square is equal to AE square plus BE square. In triangle AED, angle AED is equal to 90 degree. So AD square is equal to AE square plus DE square by Pythagoras theorem. Now AB square minus AD square. See, AB square minus AD square. AB square minus AD square equal to AE square plus BE square minus AE square minus DE square because we are subtracting this from this. So from 2 and 3. Now A square get cancelled. You will get AB square minus AD square equal to BE square minus DE square. But still we are not getting RHS. So you know, AB square minus AD square equal to, instead of BE square minus DE square, I will write BE plus DE and B minus D. Factors of A square minus B square are A plus B and A minus B. Now B plus D we can't do, but B minus D we know. B minus D will get BD, and instead of BE I can put EC. Instead of B I can put EC. So EC plus D, B minus D, you know, BD. Now tell me, EC plus D is what? DC, right? So DC into BD, because D dash E dash C. So therefore AB square minus AD square equal to BD into DC, or CD you can write. AB square minus AD square is equal to BD into CD. तो स्टूडेंट्स, थैंक यू फॉर वॉचिंग दिस वीडियो. आपको ये वीडियो पसंद आया होगा तो डोंट फॉरगेट टू सब्सक्राइब एंड लाइक.